You know that feeling when you're coding and you think to yourself, wait a second, I've solved this exact problem before? Well, today we're going to talk about a concept that helps you stop reinventing the wheel and start coding smarter: software design patterns. Let's jump in.
Okay, so to really wrap our heads around what a design pattern is, let's use one simple analogy that makes everything click. Just think about it this way. When you're building something, you have two basic options. You can follow a recipe, or you can work from a blueprint.
And that's really the big question, isn't it? When you hit a wall in your code, what are you actually looking for? Do you need a super specific step-by-step list of instructions, or do you need a high-level plan that just guides you toward your own unique solution? That distinction, well, it's everything.
So let's really break this down. On the left, you've got an algorithm. That's your recipe. It's a clear, fixed set of steps. Do this, then do that, then this, and you'll get a predictable result every single time. But on the right, you have a design pattern, and that's your blueprint. It doesn't tell you exactly which nail to hammer first. It shows you the final structure, the features, the end goal. The exact way you get there, that's up to you. It's all about being flexible.
Okay, so with that whole blueprint idea fresh in our minds, let's put an official definition on this thing.
So here it is. A design pattern is a typical, reusable solution to a problem that developers run into all the time. The keywords there are typical and reusable. We're not talking about some revolutionary, brand-new idea. These are the time-tested solutions that have just proven that they work.
And this part is absolutely crucial. You don't just find a design pattern online and copy-paste it into your editor. It's not code. It's a concept, an approach. You take the general idea, the blueprint, and then you implement it in a way that actually makes sense for your specific project. And to make it even more clear, let's talk about what a pattern isn't. It's not a library you can just import. It is not a single function that you can call, and as we've seen, it's definitely not a rigid, step-by-step algorithm. Think of it as a higher-level strategy that you, as the software designer, get to bring to life. Now, you might be thinking, okay, if these are just abstract concepts, how does anybody learn them or talk about them? And that's the beautiful part. They actually have a formal structure, which makes them way easier to understand and apply than you might think.
Pretty much every design pattern you'll ever find is broken down into these four parts. First, the intent. That tells you what problem it's trying to solve. Then you get the motivation, which explains why it's a good solution. Third is the structure. This is the actual blueprint part, showing you the classes and objects and how they all fit together. And finally, you'll usually get a code example to make it less abstract, showing you how it might look in a language you already use.
So once you learn how to read a pattern using that structure, you suddenly unlock this massive toolkit of solutions that smart developers have been building and refining for decades.
And here's the great thing. While there are dozens of patterns, they're not just some random jumble of ideas. This whole world of solutions, this huge toolkit, is all neatly organized. It all comes down to just three main categories. First, you have creational patterns. As the name implies, these are all about the best ways to create objects. Then you have structural patterns, which are about how you assemble objects and classes into bigger, more flexible structures. And finally, you have behavioral patterns, and these guys are focused on how objects can communicate effectively and share responsibilities. And inside each of those three big categories, there are tons of well-documented, super powerful patterns. And again, these aren't just academic theories. These are battle-tested solutions to real-world problems. For instance, a classic creational pattern is the singleton. Its whole job is to make sure that a class has only one single instance. This is perfect for something like a database connection or a settings manager, where having duplicates would be a total disaster.
Then for a structural pattern, there's the adapter. This one is a total lifesaver. It lets you make two incompatible interfaces work together. You can think of it like a travel adapter that lets you plug your charger into a foreign wall socket. The adapter pattern does the exact same thing for your code. And in the behavioral camp, you've got the observer pattern. This lets some objects subscribe to what's happening in another object. So when something changes, they get notified automatically and can react. It's the secret sauce behind so many event-driven systems. And believe me, that's just barely scratching the surface.
I love this quote because it just says it all. They are like pre-made blueprints that you can customize. You're not starting from a blank page, you're starting with a proven design, and then you make it your own.
So after all of that, what's the one thing you should really take away from this?
It's this. Learning to recognize and use design patterns, it fundamentally changes how you think. You stop thinking about just the next line of code, and you start thinking about the architecture. You're making the leap from being a coder to becoming a true software designer. So I'll leave you with this question. Think about the code you're working on right now. What's that one annoying, tricky problem that you keep running into over and over? Chances are, there's a blueprint for that.